Hi, Dr. Bear again. We're continuing the tutorial on plotting block vectors. We started last time by plotting a block sphere. This is that very same script. Let's run it. It gets us this block sphere. We'll dock that. Let's close that. I'm going to start a new script. I'll dock it also. And if I close this, what I'd like to do is just put here plot block sphere. Save this over another script I started. Visualize block vector. So if I run this, it calls the other script and makes that plot. That's nice. For now, I'm going to comment that out so we can see what we're doing in the command line here. So first off, let's define a couple of vectors. These represent our computational basis states. So if I run that just to see, okay, things work properly. Now let's define a helper function that will convert this to a density matrix. It'll convert any ket to a density matrix. I can do that in the bottom of this script here. So if I type function, so the name here stands for ket to density matrix. We're going to feed it some ket, and the way to convert it to a density matrix is just to take the outer product. So I use this apostrophe to get the conjugate and transpose of the ket, which gives me the bra, and then we multiply them, and that's our outer product. So for example, let's just try that. If we run this, here's our ket 0 and the density matrix that results, that's correct. Let's also make a function that converts a ket to a block vector. So this function is going to call the previous function, and it'll convert that to the density matrix. So we need to define some constants here for this function. There's the bit flip operator. There's the z operator. So these are actually matrix operations here as I define y. And 1i is the imaginary number in MATLAB. So this gets me the x component of our block vector. And there are the y and z components. Let's just test this now. Okay, there's our coherence vector. What happens if instead we feed it ket 1? Okay, there's the vector for ket 1 and then the vector for ket 0. So let's suppress some of these outputs, like this one in particular. It's a bit distracting. Run it again. Okay, those are our density matrices, and I see that this should be rho right here. Oh, I'm sorry, no, that should be lambda. This should be lambda. It's what happens when I'm not careful with copy-paste. Now, I'm going to add a helper function that will put this on this axis function. Now, since I have defined these other helper functions, I'm actually going to just feed this the ket, some ket, any ket, and then we'll convert that ket to the coherence vector or block vector, and we'll use the line command. So the way this works is you give it x data, y data, z data. In particular, we want to draw vectors from the origin to the tail of our, or I guess the head of the lambda vector. So the x points are 0 and lambda 1 in a MATLAB array, or yeah, I guess it's a MATLAB vector. Same thing, except lambda 2 for the y components, and then the z coordinates, lambda 3. I'm going to change the line width a little bit. Make it 2, I suppose. And let's see how it works if I give it a marker. Okay, so now I can just type here plot block vector, and we feed it a ket. Let's try ket 0. It didn't like that. Too many input arguments. So maybe, oh yeah, I think that should be marker. And there it is, you can see it there. Instead of plotting ket 0, let's let the Hadamard transform ket 0, and that'll throw an error because I probably didn't define the Hadamard. So what I need to do, I'm going to just, down here I defined this x, y, and z. I'm going to copy them in my helper function and bring them out. We'll make a constant section. The Hadamard transformation is this. Okay, that should satisfy when I run this now. Oh, another error. Where? Nice thing about MATLAB is I can just click and it takes me to the error. Okay, I needed to close that parentheses group. Save, run, and now it's plotted the plus vector. Similarly, I can plot the minus vector. So to clean this up a little bit more even, I'll copy this, I'll paste down here helper functions. And then we can uncomment this plot block sphere. I actually need to move it. It needs to happen before we plot the block vectors. That way it's given, it shows up as the background for the block vectors that we wish to plot. Okay, so that's a very basic tutorial on adding block vectors to a block sphere that we drew. I used some helper functions here. I made one that converts the ket to a density matrix, and then another one that converts a ket to a coherence vector, or more specifically a block vector. And then we used that conversion from ket to block vector, and we actually made a function to plot the thing. This actually employs code reusability, which is a helpful thing when programming. It helps you get your code right once and then reuse it without having to rewrite. Thanks for watching. Hope you enjoyed that. Feel free to subscribe to the channel, like the video. Thank you.